Hello and welcome to the BAL External Tiling Solutions for Balconies and Terraces CPD. My name is Allan Garland and I'm the Specifications Manager for the Southwest. Unfortunately, as this is a pre-recorded CPD, we won't be able to take any questions during the seminar. There will be an opportunity to talk to one of our Specifications Managers after the CPD by following the link. BAL has a proud history. We were founded in 1962 by the tile manufacturers that constituted the British Ceramic Tile Council. As tiles and materials were changing, there were no specific products or guidance for fitting tiles. The industry was starting to experience tile installation failures. To ensure tiles could be used successfully and grow as an industry in the UK, the council formed a specialist materials company to develop high quality products for tiling installations and provide a comprehensive technical advisory service for the industry. BAL was formed by the industry to serve the industry, a value intrinsic to what we do today. As well as the specifier benefits listed, BAL are a trusted partner for commercial projects. For external tiling, we are the exclusive partner in the UK of our sister company Gutschar, a specialist German construction company with over 25 years commercial experience. BAL's full solution for external tiling is the only true full system for one manufacturer in the UK. We provide mats, drainage, edging, through to adhesives, grouts and sealants. The aim of the CPD today is to run through the key topics listed on this slide and also to try and impart some of the knowledge and experience we've gained over the years working on this type of installation. The benefits of external living spaces. The demand for usable external living space is increasing. In September 2011, a publication by the Royal Institute of British Architects, The Case for Space, showed results from a survey that indicated 49% of people moving home wanted to do so for more outside space. The larger demand and more popular than the size of rooms or proximity of local services, which both achieved 42%. One of the benefits listed on this slide is added value. Tiled terraces, patios and balconies are often viewed as extra living space for potential resale. External living spaces in commercial environments can be used for a variety of different things. Restaurants, pubs and cafes, for example, will use this space as an extension of their internal area to create more covers and in turn create more revenue. An office environment perhaps could use this area as a breakout space or a nice relaxing area for their staff to enjoy. The broad variety of design and type of tile available to specifiers makes it possible to create a beautiful, durable area which, when specified and installed correctly, will last decades with little or no maintenance, ensuring perfect, lifelong installations. We estimate that more than 50% of all external coverings in Northern Europe are damaged in some way or another. This damage can include cracked tiles, frost damage, efflorescence and moisture staining, and in this section of the CPD we're going to talk about these failures and try and explain how and why they might occur. Water can enter the tiled installation at the joints. This water then travels through the capillaries and sits at the lowest point. Once the temperature increases and the water is slowly released as vapour, which permeates through these layers, some of that moisture will exit back through the joints, whilst the water forced against the tile may not escape. This traps the water until saturation point is reached, and the more water trapped, the greater the risk of damage to the tiles. Voids will then form during cooler periods and the screed becomes unstable. Cracking in tiles can be caused by many sources. There could be movement in the background perhaps, a lack of expansion joints, or even a lack of solid bedding. Let's take solid bedding for example. This causes there to be voids in the adhesive beneath the tile. Those voids could fill up with water and during the 3-4 cycle would expand and contract and cause issues down the line. Another issue with the lack of solid bedding is that if anything heavy is dropped on this air pocket, that will definitely crack the tile. Frost damage is normally due to the tile not being suitable for external use and not being temperature stable. It causes the tile to break down, and once you see the type of breakdown pictured, excess water will be allowed into the underside of the tile, causing further issues. Efflorescence build-up can be quite unsightly and difficult to remove. These can be calcium, potassium or sodium based and are normally caused by excess moisture present in cement-based build-ups. The British standard recognises the need for evacuating water quickly and efficiently. Taking the water out of the adhesive bed in assembly reduces the risk of all of the problems faced by modern external constructions. Water staining of tiles and slabs indicates porosity in the covering and can also leave a soluble salt stain, which can be very difficult to remove. Pre-sealing may afford some protection, but suitability should be checked with the manufacturer or supplier prior to specifying. Water-sensitive tiles and slabs should not be used externally. The adhesive should always be a rapid setting white product, preferably with a low water demand. The adhesive should be applied evenly and never in spots or excessive thicknesses. Now, the images on this slide demonstrate why. The top image demonstrates staining due to spot fixing, and the bottom image demonstrates staining due to an excessively thick bed. This causes the adhesive to dry out at different rates. Now, the adhesive in the middle of these tiles may never fully dry out. We can prevent all of the issues seen in the previous slides simply by specifying the right combination of products and materials. We will now be looking at the different types of assembly options available to us. In this section of the CPD, we will be looking at the positives and negatives of all the listed assembly options, but please remember to avoid unprotected cement-based backgrounds and excessively thick adhesive beds. Traditional screeds. Sand and cement screeds can be installed fairly quickly and cheaply. Most contractors know how to layer sand and cement screeds, and it should be cure and dry within 21 days or 3 to 4 weeks. This could be extended in wetter periods of the year, but once that screed is cure and dry, we can then waterproof it. As mentioned in the previous slide, a sand and cement screed could take a long time to dry if the weather is against us. Also, if the screed is not waterproofed, the screed will absorb large volumes of water, and during the freeze-thaw cycle, this will expand and contract, causing a loss of integrity within the build-up. Installing onto a gravel bed. Installing onto a gravel bed is very easy, fast, and cheap. The honeycomb texture of the gravel will offer a very good vertical drainage. Installing onto a gravel bed does have its downsides. Let's take open joints for example. The open joints can encourage retention of detritus, and this in turn can encourage weed growth. The picture depicted on the bottom left hand side shows quite a thick tile. This tile needs to be that thick because the gravel bed is not supportive and the tile will need to support itself. On the bottom right hand picture you'll see quite a lot of moisture staining on some of these tiles. This is due to the fact that although it's a very open texture, the gravel can wick water back up into the tile, and if we don't have a sufficient fall in this installation or pooling underneath the tiles, this could cause moisture staining. Pedestals. Pedestals are easy, fast and cheap to install. Some of the downsides experienced when installing a terrace using pedestals could be water staining, for example. Water staining normally occurs when we use cement or concrete pedestals. The water tracks back up these cement and concrete pedestals, causing the staining you can see in the images here. And also, as with the slide before when we were looking at gravel beds, the tile needs to be self-supportive, so a minimum of 20mm porcelain or a 35mm natural stone would be needed. Open joints can lead to retention of detritus, and weed growth from moss and mould falling through these joints could lead to the blockage of drains. Drainage mortar. A drainage mortar is a very cavity-rich structure with lots of capillaries. It drains through quickly and efficiently, offering very good vertical drainage. And as it's combined normally with a quick-setting cement, it can be quicker to tile, normally 24 hours instead of 21 days, as with the normal sand and cement screed. The suitability of most tile thicknesses means that instead of using a 20mm porcelain as you would with a pedestal or an unsupported system, you can use, let's say, a 10mm porcelain as you would internally. One of the downsides when using drainage mortar to install tiles on a terrace or a balcony could be the poor drainage on the horizontal plane. This can cause build-up at the perimeters of soluble salts and lime, and this means that the water cannot evacuate the terrace properly. This can then mean that the water will sit in the build-up and then wick up back through the capillaries of the drainage mortar itself and cause unsightly stains in the tiled finish. On the right hand side of this photo you will see the addition of a drainage mat. As we will go on to explain, this is the solution. So, to the solution, a drainage mortar in combination with a drainage mat solves the problem of poor horizontal drainage, while still allowing excellent vertical drainage of the drainage mortar. The mat itself creates an air gap between the surface of the terrace or balcony and the drainage mortar. This allows freedom of movement for the water to drain effectively and freely into the rainwater evacuation points. The image on the left-hand side shows an external terrace in Germany installed with only drainage mortar and no mat. Installed for about 12 months, we already see a lot of moisture staining on the tiles. We were asked to remove a section of these tiles and relay them using a drainage mortar in conjunction with a drainage mat. We lifted the tiles and relayed them using a drainage mortar and a drainage mat. The area was then left for about 12 months when we came back to take these photos. It's quite evident from these photos that the combination of the drainage mortar and the drainage mat allows free movement of water and high capacity drainage from underneath those tiles, and this in turn helps stop any unsightly moisture stains. Problems caused by water are solved by using a capillary passive mat and a drainage mortar combined. As you can see from the images depicted, the capillary passive mat and the drainage mortar allow for free movement of water along the vertical and horizontal planes, following the falls and the gradients created in the construction stage of the balcony or terrace. If we don't use these capillary passive mats or the drainage mortar, we will have trapped water at the lowest point of the terrace, and eventually this will rise back up and cause issues in the tiled surface. Just like all cars are not made the same, not all drainage mats are made the same. High quality materials are needed when manufacturing products of this nature. High quality fleece, for example, helps prevent the buildup of calcite on the fabric, provides high drainage performance, and also high quality products allows us to provide a longer guarantee. On this slide, we aim to show you the difference between a high-grade fleece and an alternate fleece. We've carried out two experiments, one on pour and one after 12 hours. As you can see, on the high-grade fleece, the water absorbs instantly, whilst on the alternate fleece, we have some surface water. After 12 hours, you will see that there is no pooling and is totally dry on the high-grade fleece, whilst the alternate fleece has some wet areas and pooling. This water will in fact wick its way back up through the drainage mortar using a capillary action into the stone, causing unsightly moisture stains. Likewise, when using a mesh system, a poor quality mesh or matting design can lead to the mesh collapsing into the drainage space of the mat and reducing its effectivity. Based on the German DIN test, the Gutschar 8mm mats have twice the drainage of the closest competitor, and the 16mm mats have 3 times the drainage of the closest competitor. The next section of this CPD deals with the system design. The next slide will show how we manage that water once it reaches the perimeter of the balcony or the terrace. What we really want to do is manage the water so we don't end up with unsightly moisture staining like the pictures shown. Using specifically designed drip edge profiles and a guttering system is the best way to manage that water once it reaches the perimeter of the balcony or terrace. This water can then be guided into your existing rainwater drainage system. There are many considerations to be made when designing a terrace or a balcony. One of the main considerations that we would look at would be whether or not the balustrade fixings penetrate the waterproofing layer. If this isn't dealt with correctly at design stage, it could cause quite costly and damaging issues in the long term. Safe and comfortable transitions. Waterproofing at building connections can be extremely difficult when contending with various access requirements and door sill transitions. If water is allowed to fall back to the threshold, then the problem can become dangerous. Water can travel up and over the waterproofing, or worse still, get behind the waterproofing and track back. Note that damage at these critical areas can cause big problems for even the smallest of balconies. Damage to the building fabric and structural element can also occur. Thermal bridging can also become a difficulty to design in with functional waterproof assemblies in awkward locations. With low profile comes high risk. There's a risk of water migration from external to internal, loss of heat through materials. We're often reliant upon sealants and proprietary seals, which is never good. As it's a door transition, wear will cause materials to become dislodged. This is no true barrier to water. Traditional building regulations require that 150mm upstand is required from the primary moisture or vapour barrier up to the sill of the door. Although the 150mm upstand advice still holds good, we are aware that builders and designers want or are required to provide an accessible threshold from the apartment to the balcony. To move away from 150mm step dimension may seem risky, but with careful design we believe it's possible. Although NHSBC cannot design the balcony or the access to it, we have set out a series of principles for builders and designers to follow. There are systems which are designed for prevention of water ingress through the door threshold and can reduce the transition by specifying the correct combination of barrier drain and matting. However, for wheeled accessibility, the transition is required to stay level, as we can see on the next slide. Ramped areas may have to step up to a specific level. There are drain grates available which will allow this adjustment to be made within the grate, and use the grate as part of the ramp. Debris collection can become a problem with external drainage. Leaves and other organic material can collect. Drains are not always cleaned regularly or correctly. Freezing water can cause drains to become blocked, especially if the water is not clearing quickly enough. These drains should have no obstructions. Consideration of the environment is essential. Have we got moss growth on the roofs falling off and into the drains? Are there trees or woods nearby with the leaves and the leaf fall affecting the drainage? Is the water table high on a ground terrace? Is that going to need us to add in extra protection? The direction of the external area, wind, sun, thermal aspects, wind shear on balustrades and movement. The image in this slide depicts the use of a drain grate with a drainage mat. The drain grate, in effect, creates a barrier or air gap between the tiled area and the threshold. There is no true barrier to water within this drain grate, and it allows the water to pass through directly onto the terrace. The falls in the terrace or balcony then takes that water away within the capillary passive mat. At no point is the water in contact with the drainage mortar or the tiled surface, which means we can pass high volumes of water using the whole terrace to disperse the water to the rainwater evacuation point. Some other considerations when designing a balcony or a terrace could be, are we in a heavily wooded area? Is that leaf fall and detritus going to fall onto the terrace or the balcony and cause a blockage within the drain? Are we going to have a high accumulation of rainfall? And does the flow resistance of the drain grate allow us to deal with that high accumulation of rainfall effectively? And so to summarise, we have looked at the benefits of external living spaces and how tiled coverings are achieved in external applications. What types of materials ensure the best results, including all types of tile? How to avoid potential issues by specifying the correct system assembly and avoiding products and materials that carry a high risk or a high number of risks. Breakdown of popular assembly characteristics to understand more why modern drainage mortars and mattings are so important to longevity. Important design considerations and vital considerations for success. Installations and drainage transitions between thresholds. How functional transitions form part of the active assembly. Now we'd like to show you a couple of case studies. On this slide we'd like to talk about the Schloss El Mal. The Schloss El Mal renovation was carried out after it was gutted by fire in 2005. The Schloss El Mal Castle and El Mal Castle Resort was rebuilt and completed in time to host the G7 summit in 2015. The balconies and terraces of the courtyard featured Brazilian quartzite tiles. This sensitive stone was protected from efflorescence and water staining with the AquaDrain EK passive capillary mat and drainage mortar. The combination of these two products ensured effective drainage of water away from the stone, avoiding damage. And now the Badner Hut. The terrace on the Badner's Hut was Europe's highest renovation at 2,608 metres. The sun terrace of the Badner Hut is in the Austrian Alps, facing the most severe of weather conditions. The materials were transported to site using a helicopter, as it's only accessible by foot. The owner was looking for a solution to protect the terrace from extreme mounting conditions with temperature ranges from -20 to +35. The solution was found in the Gutchar system technology. An AquaDrain EK drainage mat and drainage mortar was installed. The surface water is drained through the mortar into the drainage mat and expelled into the guttering, preventing water being trapped and the freeze-fall cycle damaging the natural stone. Thank you for your time, and please, if you have any questions, do get in touch.